Welcome back to one more session of your WOC. This is your Vani ma'am back again with the NEET series. Yes, this is what was the most expected, students. We have done our board exams wonderfully, correct? Chemistry paper went very well, and most of the students, I will tell you, maximum of the students said, ma'am, we are going to get full. It's a very happy news. Yes. Now our journey starts with the NEET series. Very important. Nothing to worry. I'll be sending from my end completely everything. Yes. Please follow the channel. My request, inform all your friends. We'll be doing organic, we'll be doing physical, we'll also be doing inorganic. Both grade 11th and grade 12th also. I'll be picking up topics of grade 11th and grade 12th also. We are going to go very leisurely, but we are going to complete everything. Let's start off. Before I start the session, yes, I request all the students to like the video. Yes, comment, share the video, subscribe to the channel, and thanks for watching. It's a request from all of you. Yes, so please share it to everybody because it is free of cost. Now students, nothing, education has to be shared, so please share the video to everybody. Yes, so coming up with loads and loads of videos for your NEET. I'll be giving you tricks, I'll be giving you very important thing where to apply. So I'll be explaining the trick first, then I'll be giving you a question, we'll be solving the question, and we'll also understand what to do and how to mark within the given time. Let's start off. So first I have decided, as the student asked me to do, I am doing organic chemistry first, then I will go to physical, or your wish inorganic, that's okay. Inorganic, then I'll go to physical. Okay students, so I'll be picking up different topics from my end, and all the videos are free from my end. So please share it to maximum students. As I'm there with the grade 12, I'm also there with grade NEET exam aspirants also. Right, my Telegram channel link is given below in the description. Please join. Let's start with the first important thing. So first important trick, that is your trick number 1. Remember students, yes, your trick number 1. Okay, let us put hashtag. Okay, done. Trick number 1, that to organic chemistry, I'll be picking up as I said. So we are going to do topics like hydrocarbons this time, then GOC next, like that I'll be doing everything. So remember, trick number 1, easy. More the S character. Okay, if the S character is more, means more the S character, what will be more? The carbon which is attached to the particular thing. Suppose if your carbon is attached by a triple bond, if your carbon is attached by a double bond, if your carbon is attached by a single bond, so remaining all are hydrogens. So in the case 1, in case 2 and case 3, remember students, here the carbon whichever has more S character, that means more is the electronegativity of carbon. Correct now students? Yes. So what will happen? More is the Z effective nature. Correct? Z effective nature would be, the pull would be more. Correct? Then automatically what will happen? It will easily release your proton. So S character is more, means electronegativity of carbon will be more and Z effective will be more. So what is going to happen? The carbon which is there will pull the electron density and release your proton easily. It will release your proton. So when it is releasing proton, what is the thing? The proton released means it is acidic character is more. Correct na? Acidic character is more. So remember, check the S character. So in case 1, first case, this is sp hybridization, the S character is 50%. In case 2, the S character, how much is the S character students? This is sp2 hybridization, so 33%. In case 3, this is sp3 hybridization, so it is 25%. So you only tell me C triple bond C has 50% S character, C double bond C has 33% S character, C single bond C has 25% S character. This is sp hybridization, sp2 and sp3. Done. So which will be more acidic? This carbon will be more acidic. Yes, remember that. Let us solve one question and see. See this question. This was asked in NEET 2017. Options are given. Which is the order of acidity? You only check. First order is alkynes, then comes your alkenes, Then comes your alkanes. Correct, na students? Chalo. Now let us see the question. Where are options? A is there, B is there. Okay, these two options, alkynes are there. Now check. Compare to the first and second one. After alkyne, again you have an alkyne. Yes. So then alkene, then alkane. Correct. In the second case, what happened? First alkyne is given, then alkene is given, then alkyne. So the correct option is this is more acidic. So option A is more acidic in nature. So trick is easy, very easy. Let us see one more trick in your basic organic chemistry. So trick number 2 is nothing. Remember students, what is it? First of all, if they ask you any question based on conformations, okay, conformations you have, na, your staggered, eclipsed, like that. If they ask you a question, they will ask you one question called stability, which is more stable. Stability is what they're going to ask. So remember students, only one trick. Yes. So more bulky groups, which groups? Alkyl groups rather. Yes. So if the bulky groups, more bulky groups are there, and that too, the bulky group should be far apart. If the bulky groups are far apart, what will happen? Steric repulsions, whatever repulsions are there, no? The steric repulsions are less. Correct. If the steric repulsions are less, what will happen? The particular conformer is most stable. Correct. So bulky groups, they should be very far. Then repulsions will be less. Then it is more stable. Let us use this, see this question. 2010. In the following, the most stable conformation of N-butane, you only observe case 1, okay, right? In case 2, all right. In case 3, okay. And case 4. Now, you only observe in this particular case, the two bulky groups are very near, not stable. In this, the bulky groups are very far away. Yes, so repulsions are less in this. So if the repulsions are less in this, automatically this is most stable compound. Correct? Check this. These two are nearby, not stable. Check this. These two are nearby. These are nearby. These are nearby. So the most stable compound is B. Correct? Easy question. Next, let us see one more. Right. One more important trick. Yes. Trick number 3. What did they asking you? If they are asking you, right, halogenation compounds, like, they're asking you what are the products of so and so. So normally, remember, if they ask you, careful, if they ask you any question based on chlorination or rather halogenation, you very well know chlorination or halogenation, we are going to get different products. We get mixture of products. Correct. Now, if they ask you monochlorinated product, if they ask you, they want monochloro product or chlorinated product, what should you remember? Only one thing. Only one trick is, remember, if you want monochlorinated or single chlorinated product, what is important? Your important thing is all the hydrogens should be similar. All hydrogens should be similar. Hydrogens to be similar. If they are similar, only you will get single product. For example, let us see this question. See this. 2019, this is what isopentane they gave. Okay, 1, 2, 3, 4. This is my iso group. Correct. Now check here. That this has how many hydrogens? In this case, there are two different types of hydrogens. So not possible. You get getting mixture. In this case, 2,2-dimethyl butane. Let us see this carbon. CH2, CH3, 2,2-dimethyl. Okay, in this also you have different types of carbons. This is one carbon having CH3. This is one more carbon having CH2. So not possible. Neopentane. Okay, yes. Check students. Neopentane, if I check, this is your CH3. This is your CH3, this is your CH3, this is your CH3. Done. All carbons are similar. All hydrogens are similar, rather. Carbons, no hydrogens. So, because all hydrogens are similar, you will get only one product from here. In ultraviolet light, when you supply, you will be getting only one compound. I'll write it in the next page, or let me write here only. I'll be getting one compound, that's nothing but your monochlorinated compound. And N-pentane, you very well know. See this, N-pentane. Okay. This is CH3 different. This is CH2. This is CH2. This is CH2. This is CH2. 3-pentane. This is not there. Pentana. So last is CH3. So that means for monochlorinated compound, you should check for similar hydrogen atoms. Only that will give the product. Easy? Easy. Next compound, next question. Right. Trick number 4 rather. Let me see. Yes, trick number 4. What is trick number 4 to remember? Trick number 4 to remember here is, check students, whenever they give you any particular paragraph rather, any particular question rather. So what to remember? I said read the paragraph completely and there will be one clue in the question. What is that? So if there is a paragraph given, let us see one question. Paragraph is given to you. You have to write the products. So what to check? Check for the reagent. Check for the reagent. Reagent will tell you the mode of reaction. Mode of reaction. Let us see one example. See this. Hydrocarbon A reacts with bromine by substitution to form alkyl bromide. Okay, hydrocarbon A is reacting with bromine, okay, by substitution itself. Then it is giving alkyl bromide, okay, by Wurtz reaction. Oh, this is the clue. See here. It is giving by Wurtz reaction, they're saying. Done, done, done. Easy. I know from Wurtz reaction. Important thing is Wurtz, I can prepare which type? Even number of carbon atoms. I can prepare even number of atoms. Correct, na? I can only prepare even number of carbon atoms. Now you only tell me. They said it is converted to gaseous hydrocarbon. Okay. Which one? This one it seems. This one. And that gaseous hydrocarbon is. Now Wurtz reaction happens in presence of Na. It is having less than 4 carbon atoms. Oh, okay. So one carbon atom, methane, this will not form Wurtz. 2 carbon atoms already given here. Okay. 3 carbon atoms, Wurtz reaction not possible. So 4 carbon atom, less than 4 carbon atom they're saying. Okay, so less than 4 carbon atoms, it should not be 4. That means our answer lies here. Let us check. I should get a hydrocarbon which is less than 4 carbon atoms. Let's take it. Chalo. First, what is a compound? If I have to tell, I'm taking one compound. First one, C option. Why? Because I have to form less than 4 carbon atoms. Bromine I'm taking. So this is a free radical substitution. H nu I'll take. I'll be getting CH3Br. Now what am I doing? I'm using Wurtz reaction itself. In Wurtz reaction, simple. In Wurtz, double the chain. Correct. So CH3Br will react with Na with one more Br, CH3. I'll be getting CH3. That's all. This is how many? Less than 4 carbons, and that too, it is even number. Even. Easy. So the correct option is methane. Because if I take this will become double, means 2 plus 2, it will become 4. If I make this is basically, this is alkyne. Alkyne will not undergo rather, if I tell you Wurtz reaction. Alkane, if I take this also does not undergo. If I take this, 2 plus 2, it will become 4. I want less than 4. Done? Chal. Next question. Next, let us see this. With respect to the conformers of ethane, which is the following statement is true? So conformers, only one clue remember students, whenever they say conformers. Conformers or conformations are nothing but it is only spatial arrangement. Okay, it is only spatial arrangement. You're just arranging the atoms, right? In this, there is no bond angle change, or there is no bond length change. Remember, bond angle change and bond length change will not happen. Remember that. Yes, only rotation is going to happen in the particular molecule. Done. Let us go back and see which option is right. It is bond angle will remains, bond angle changes, they said, not this one. Bond angle and bond length, this is also not. Bond angle and bond length remain same. So this option is done. Chalo. Next question. The correct statement regarding comparison of staggered and eclipsed conformation of ethane. Okay, so what to remember, students? What to remember? First of all, the clue here is when you have staggered form. Okay, this is your trick. Next trick, rather trick. Remember, the trick is staggered form. There is no torsional strain. Okay, there is no torsional strain in staggered. Yes, all are spaced completely far away like this. Nothing has torsional strain. So which if it is not, there is no strain, what is going to happen, students? Okay, let us take eclipsed. In eclipsed form, rather there is lot of strain in the molecule. See here, it looks like this. You have your molecule, hydrogen, 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 one H here, one more H here, and one more H here. So only tell me here there is strain, torsional strain is there in this molecule. So what is important? They are interconvertible. So almost remember when they ask you, compare this particular staggered is stable in nature. Done. Because there is no strain, read this. The correct statement regarding comparison of staggered and eclipsed conformation is, right, here they have given staggered conformation is less stable. This is wrong. Here they have given the eclipsed conformation is more stable. This is wrong. The eclipsed conformation of ethane is more stable. This is wrong. The staggered of ethane is more stable. This is that. Easy, because staggered doesn't have any strain. Next question. Let us read this. Given. They have given this question. What are they? Are they optical isomers, identical pair of conformers, geometrical isomers? Nothing. As soon as a molecule is given, check for, so okay, the trick I have to write, let me write, students. Always remember, whenever a molecule is given to you, remember, check for rotation. If any rotation of the groups is there, that is nothing but conformers. Conformers. If they give you, if it is any D and it rotates the plane polarized light PPL right towards right or left, if they say it is optical isomers. Done. Correct. If they say cis and trans isomers, cis and trans, if you see, then it is geometrical isomer. Done. If there is no change, identical, just like your mirror images, enantiomers, enantiomers, mirror images, then it is enantiomer. But in this case, observe, CH3 was here, CH3 is here. In second case, there is complete rotation of the molecule. So when there are rotations of the molecule, they both are conformers. Done? Easy. So 1 and 2 are basically rotating the direction, spatial arrangement. Next question. Okay. Which of the following conformers of for ethylene glycol is most stable? Just now I said in all these cases, observe, okay, this is not stable because there is basically strain, torsional strain in this, strain, torsional strain. So I will not go with that. Done. Here also torsional strain is there in this. This also I will not go. So now the confusion is between this and this. What to decide? Remember the trick here. The trick here is, careful students, more hydrogen bonding, or rather hydrogen bonding is more means then important thing, this particular conformer or conformation is most stable. This is most stable. Okay, remember. Now check here, check here. In case one, do you have hydrogen bonding? No, this is also H, this is also OH, but here it is very far. But in this case, there is a hydrogen bonding between, observe, let us see, compared to this and this we will check. Okay, now, okay. So here there is hydrogen bonding, but compared to the first one, let us see in this way. Suppose if I take the first one, open it. Okay. Here, if this is a molecule, okay, done. You're right, students. Now check. Here you have a hydrogen bonding between hydrogen and oxygen. This can form hydrogen bonding between one more. Here it can form one. But in this case, only one. Na? So the hydrogen bonding is there, but only one. But here hydrogen bonding, two bonds are forming. So this is a stable conformation. Yes. So due to hydrogen bonding. What is this conformation, students? Yes, this is Gaussian conformation. Correct. Next question. Let us see. Liquid hydrogen can be converted to mixture of hydrocarbons. Okay. By what? Nothing, students. When they give you mixture of hydrocarbons means this is nothing but cracking. Cracking is nothing. You get mixture of hydrocarbons. So basically what to remember? Cracking means what? Cracking is higher hydrocarbons. Okay. Higher hydrocarbons are getting converted to lower hydrocarbons. Okay, what hydrocarbons are these? These are gaseous. First of all, higher hydrocarbons are always liquids, lower hydrocarbons are always gaseous. Remember this. So crack. Next question. A compound of molecular formula C7H16 shows optical isomerism. What is it? Okay, what is the clue? When they say optical isomerism, only one. So trick is, remember, to show optical activity or optical isomerism, right? The particular compound, what should it have? The compound should have chiral's carbon. Okay, the chiral carbon, more the optical activity. Done. Now you only check, go back. Now 2,2 dimethyl pentane, 2,3 dimethyl pentane. Okay, so in the second position and third position there is, so 1 2 3. Okay, in the first position there is methyl, then hydrogen. Done. Then in this it is pentane. Okay, CH3, this is CH3, this is H. Now check. They said in the second and third. Okay, in the second and third. Okay, 1 and 2. Okay, second and third they have particular 2,3 dimethyl pentane. So 1 2 3 4 5. Yes, done. So this is my 2,3 dimethyl pentane. If you observe, this is chiral carbon. Now 2,3 dimethyl butane. Let us see here. This is chiral carbon or not? This is chiral carbon or not? This is CH3. This is CH2. This is CH3. Okay, done. Now this is CH3. This is CH3. Okay, done. Now let us see 2-methylhexane. 1, 2, 3, 4, 5, 6, 7. This is your methyl. None of the above. Now you observe in this compound, yes, it contains one chiral carbon, only one, right? Which is an atom which is bonded to 4 different groups. Correct? Yes. So here what happened? In this case, this carbon is attached to this different carbon here, different carbon here, different carbon here. Correct na? Yes. So what happened in this case? This is same, this is same, this is same. That's why this is not chiral. But here it has 4 different groups. 4 different groups. That's why group 1 or option 1 is going to show optical activity. Easy. Next question. The reaction of ethyl magnesium bromide with water would be easy question, students. Ethyl magnesium bromide. See this, you're taking magnesium bromide. I'll tell you one simple trick here. Yes. So Grignard's reagent first always undergoes hydrolysis. Okay. So what you're going to do is exactly break the bond here. Right. Now check. Your water molecule is there na? H and OH. Try to add hydrogen here, OH. That's all, students. It is C2H6 plus MgOHBr. That's all. So what is our answer here? The answer is ethane. Then ethyl will give ethane. Simple. Next question. In commercial gasolines, the type of hydrocarbon which are more desirable. Okay, basically commercial gasolines means what? I'll show you, students. Commercial gasolines are these. Check. So commercial gasolines means they are mixture of alkanes. See this. They are mixture of alkanes. So commercial gasolines are mixture of alkanes which are formed. Okay. So the quality of this one is determined by branched chains. So they've asked you in commercial alkanes what are they? It is nothing but they are branched. branched hydrocarbons. So it is mixture of alkanes. Mixture of alkanes which are branched. You only see it starts from C1, C15, C16, C18, C30, greater than that. Okay. So gasolines, when they ask, use it. Next question, let us see. The most stable conformation of N-butane. Oh, easy, easy. Just now I said no. Remember one clue in conformation. Only one thing. Order of stability. Okay, if you remember this trick, this is easy. Order of stability. What is the order, students? Always remember, wherever, whichever example you take, staggered, most stable, and that too antipart. Then greater stability than Cauchy. Then SCU both we say. Then this is more stable than eclipsed. Okay, this is more stable than eclipsed. So whatever they give you, remember, first is always most stable is C. Staggered is most stable. The least stable compound is this. Least stable eclipsed. Because why? Because there is a lot of torsional strain in this. Correct na? Next question. Which of the following reactions is expected to readily give hydrocarbon product in good yields? Simple, students. Hydrocarbon. First of all, let us differentiate. Now you see, electrolytic method, which is which one? Colps. Okay. Silver salts of carboxylic acid. What is this? This is Hunt's-Decker reaction. Hunt's-Decker. This is what in chlorination, HNu, it is free radical substitution. Here you have an alcohol here and you have Cl group. So this is nucleophilic substitution reaction. You only tell me. Colps is a method which gives us two products. What are they? One is at the anodic compartment, one that is nothing but hydrocarbon. You're taking one alkyl group. So later on in the mechanism, if you see RR, at the cathodic compartment, you are going to get two gases. One is your anodic compartment, you will be getting alkane and carbon dioxide. At cathodic compartment, one gas which is hydrogen gas. So in this case, what is going to form, student? RBR. In this case, you'll be getting mixture of compounds. Finally, you'll be getting CCl4. Rather, if you take 1 chlorine will get replaced. So you'll be getting mixture. Correct. In this case, what will you get? You will be getting an alcohol in this case. You'll be getting an alcohol in this case. Simple. So remember, what is it? So maximum yield. This is the trick to remember. What is it? Maximum yield of hydrocarbons is given by which process? Kolb's electrolytic. Kolb's electrolytic method. Electrolytic method. Is it okay, students? Done. Next, let us see one more question. In free radical chlorination of methane, the chain initiating step involves the formation. Easy. So basically, one thing remember, in free radical substitution, what steps are there? Chain initiation. Chain, basically, once it is started, slowly it goes. Chain propagation. Then it goes to chain termination. Correct? No. So chain initiation step always happen in the presence of HNu, and you are going to generate free radicals. Free radicals. Correct? So what is the reaction here? They said it is nothing but chlorine in HNu in the chain initiation process. What is it, students? It is nothing but 2 chlorine free radicals. So the answer is this. Next question. Okay. Next question. The reactivity of hydrogen atoms attached to different carbon atoms in alkanes has order. Oh, reactivity of hydrogen. So remember, reactivity of hydrogen atoms attached to different carbon atoms. Easy, only one. What is the trick here? Remember, students, always tertiary free radical. Now these are all basically what happened to hydrogen atom. Always whenever you take alkanes will form free radicals which are very highly reactive species. Correct, na? Done. So let us see. So the order of free radical stability. Free radical stability. What is it, students? Check carefully. Tertiary free radical is more stable than secondary free radical, most stable than primary free radical, most stable than methyl free radical. Okay, methyl free radical. Done. So simple, simple. So earlier also we remember, no, tertiary is more stable than secondary, more stable than primary. So even in free radicals also this is the order. Now go back to the question. Easy. So alkenes, characteristic reaction is free radical. So correct order is this. Next question. Okay, 2020 it is given. Let us see this. An alkene on ozonolysis gives methanol, one of the product. Simple, students. I'll tell you one thing. Check. The trick here is ozonolysis process is when they say you are going to do this ozonolysis which alkenes. Alkenes were around the double bond. That's all. One important thing to remember, you're going to break the bond and you're going to form an ozonoid like this. So further cleavage, you are going to break the bond like this. Let us see. This question is given. Check for alkenes. So ozonolysis they said, na. So addition of ozone, this is not an alkene, no. This is not an alkene, no. Now you have two alkenes. This is your double bond, break here. This is your double bond, break here. Nothing. Add one oxygen here, add one oxygen. Add one oxygen here, add one oxygen. You only see they wanted methanol. Now check what are the products here. It is going to form CH2, CHO plus. What is this? HCHO. Oh, nice. This is methanol. That's all. So easy. Around the double bond, add two oxygens. That's all. Easy. The correct option is this. Next question. An alkene A on reaction with ozone and zinc, okay, zinc and water gives propanone and ethanol. Okay, propanone and ethanol are there. In equimolar mixtures, addition of HCl to alkene A gives B as a major product, the structure of B. Nothing, students. They said alkene A. One clue here, I said. Ozonolysis. They've given you one clue, see. It gives propanone and ethanol. Means how many carbons are there? Prop means 3 carbons. Eth means 2 carbons. Correct? Yes. So what are you going to do? You're going to make one molecule. Make one double bond first like this. So prop na. So 3 carbons. 1 and 2 and this 3. Make this compound. Propanol. Then eth. So eth means 2 carbons. Done. Easy. Now one side they said it is undergoing ozonolysis, zinc and water. So what should you do? I said break the bond. Break the bond. Add one oxygen here, add one oxygen here. What products you will get? You will get CH3CHO. You will be getting CH3CO, CH3. That's all. They said you are adding HCl to this. Check. In case of HCl, now you only observe the replaceable hydrogen atoms. What are they? What is a replaceable hydrogen atom? Nothing. There is no. So what will I do? I will go and directly break the bond and add this HCl. Now you only observe. This is negative, this is positive. This is symmetrical alkene. Done. Now the negative addendum goes and adds to the carbon having lesser number of hydrogens. Yes. Let us see how we are going to do the product. So CH3C, you should shift this compound, the CH3 here. Okay, just see Cl, then CH2, this is CH3. Check. Nothing, I just added one hydrogen here, one chlorine here. Done. I just shifted this compound in this way and I added the hydrogen. So I added one hydrogen here, one chlorine here. Easy, easy. So what is the compound? What did they ask me? They said the structure of the product B is what? Okay, so this is your chlorine. The answer is C part. Done. All right. Oh wow, we have learned so many questions today. Yes, so I'll be coming back with more and more questions, more and more questions. So only thing is, please send me your feedback. How did you like the video? Yes, please tell me, send me your feedback, students, send me your feedback. So please tell me, how did you like the video? Any further improvement, any further suggestions you want? So mention in the comment section. I'll be waiting. Ma'am, please do it. Please tell me how further I can do. So mention in your comment section. All the NEET aspirants, I'm there for you all. Nothing to worry. Thank you so much for watching. Come back. I'll come back with more and more questions. I'll be waiting for your comments. Please like the video, comment, share the video, and subscribe to the channel. And thank you so much for watching. Yavani ma'am signing off. Thank you.